What are fingerprints? There are three fundamental principles of fingerprints. First, fingerprints are an individual characteristics. No two persons' fingerprints are exactly alike, not even those of identical twins. Second, a fingerprint is the pattern on the inside of the finger in the area between the tip of the first joint and stay the same from the day of a person's birth to the day of they die. Third, fingerprints have general reach pattern that permit them to be systematically identified or classified. These facts make fingerprints very useful in identifying somebody beyond any doubt, and this is why police forces find them invaluable in tracking down a criminal. In more than 100 years of fingerprint record keeping, no two identical sets have ever been found, even on identical twins. A scientific study of fingerprints, known as dactylography, is used as a technique of crime detection by practically every modern law enforcement agency. Government agencies and many private businesses also use fingerprints for identification purposes. The largest collection of fingerprints is held by the FBI in America. What makes them so different? To begin with, our skin consists of two layers of tissue. One is a thick, deep layer, the corium, and over it is a delicate membrane called the epidermis. In human beings, the rows of ridges form definite patterns. In fact, the system of classifying human fingerprints was developed by studying these patterns. Fingerprint files. Modern governments keep a central file of the fingerprints of all known criminals, in addition of many other classification of citizens. Fingerprints are recorded by rolling the fingers over a pad stained with printer's ink and making an impression on an standard card. Each finger is printed separately and an additional print is made of each hand. The classification system, known as the Henry system, includes 8 basic fingerprint patterns. They are plain arch, centered arch, radial loop, ulnar loop, plain whorl, central pocket loop, double loop, and accidental or composite pattern. A person have any number of fingerprints per set of these fingerprints. Arch is a simple type of fingerprint pattern, but also the most rare. Only 5% of the population have arch prints. Plain arch pattern have ridges that being one side and end on other side, making a line looks like a heel. A tented arch has a higher, more prominent spike in the center. Loop pattern are the most common. They are found in 70% of the population. In a loop pattern, just begin and the end of a same side. Radial loop start and end on a thumb side of the finger and point toward the radius bone in the forearms. Ulnar loop start and end on the same side of the pinky finger and print toward ulnar bone in the forearm. And in every loop there is a triangular shape pattern like Greek letter delta where fingerprints just meet. In a whorl pattern, the ridges form a spiral that appear to complete the whole circle. Approximately 25% of the population has whorl pattern. There are 4 major whorl patterns and each one has at least 2 deltas. Plain whorls have one or more ridges that make a complete circle. You see small circle in the middle with concentric circle spreading out from there. There are 2 deltas imprint but on the opposite side of the circles. An imaginary line which between the 2 deltas crossing through the same part of the ridge circle. If the line does not touch the circle ridge pattern at all, the whorl is a central pocket loop. A double loop whorl has 2 or more loops combined into one part and resemble like Tai Chi symbol. If a print has 2 or more pattern or does not fall clearly into any other categories, it is considered as accidental or composite whorl. Where fingerprints may be found. Fingerprints can be found on practically any solid surface, including the human body. Analysts classify fingerprints into 3 categories according to the type of surface on which they are found and whether they are visible or not. Fingerprints on soft surfaces such as soap, wax, wet paint are likely to be 3-dimensional plastic prints. Those on hard surfaces are either patent, that is visible, or latent, that is invisible prints. Visible prints are formed when blood, dirt, ink, paint, etc. is transferred from a finger or thumb to a surface. Latent print can be found on a wide variety of surfaces, smooth or rough, porous such as paper, cloth or wood, or non-porous such as metal, glass or plastic. Latent prints are formed when the body's natural oils and sweat on the skin are deposited onto another surface. Latent prints can be found on a variety of surfaces. However, they are not readily visible and detection often requires the use of fingerprint powders, chemical reagents, or alternate light sources. Generally speaking, the smoother and less porous a surface is, the greater the potential that any latent print present can be found and developed. Collecting patent prints. Patent prints are collected using a fairly straightforward method. Photography. These prints are photographed in high resolution with a forensic measurement scale in the image for reference. Investigator can improve the quality of the images by using low angle or alternate light sources and or certain chemicals or dyes during photography, but this is usually not necessary. Collecting latent prints. One of the most common methods for discovering and collecting latent fingerprints is by dusting a smooth or non-porous surface with fingerprint powder. That may be black granular, aluminum flake, black magnetic, etc. If any print appear, they are photographed by mentioned above and then lifted from the surface with clear adhesive tape. The lifting tape is then placed on a latent lift card to preserve the print. However, fingerprints powders can contaminate the evidence and ruin the opportunity to perform other techniques that could turn up a hidden print or additional information. Therefore, investigator may examine the area with an alternate light source or apply cyanoacrylate superglue before using powders. Alternate light source. It is becoming more commonplace for investigators to examine any likely surfaces like doors, doorknobs, windows, railing, etc. with an alternate light source. These are laser or LED devices that emit a particular wavelength or a spectrum of light. Some devices have different filters to provide a variety of spectra that can be photographed or further processed with powders or dye stains. For example, investigators may use a blue light with an orange filter to find latent prints on desks, chairs, computers, equipment, or other objects at the scene of a break-in. Cyanoacrylate. Investigators often perform cyanoacrylate processing or fuming or a surface before applying powders or dye stains. This process, typically performed on non-porous surfaces, involves exposing the object of cyanoacrylate vapors. The vapors or fume will adhere to any prints present on the object, allowing them to be viewed with oblique ambient light or a white light source. Chemical developers. Porous surfaces such as paper are typically processed with chemicals, including ninhydrine and physical developer, to reveal latent fingerprints. These chemicals react with a specific component of latent print residue such as amino acid and inorganic salts. Ninhydrine cause prints to turn a purple color, which make them easily photographed. DFO is another chemical used to locate latent fingerprints on porous surfaces. It causes fingerprints to fluoresce or glow when they are illuminated by blue-green light.